Alright, in the last video we saw how to manipulate the inputs, how to configure inputs and outputs. Now we're going to be looking at how to manipulate the input and output. That is how to light up the LED and how to test for the switch as well. So to do that, I'll have to clean this part off. Alright. So let's say we want to light up the LED and in C, using C. All we have to do is just write port B dot B2 equal to 1, and the LED will light up. If we want to turn off the LED, we change this 1 to 0 and the LED will go off on this bit 2. Now if you are using port A, for example, assuming you chose to use port A or port C or whichever one, nothing happens. In writing this micro C program, the way micro C is configured, all you need to change is the AD, the port number. This B means bits. This means the port ID, alright, yeah. And this B here, this B here does not mean port B, or it has nothing to do with port B. Even if you are using port C here, this B will still remain. What this means is you are manipulating the bit 2 of port C. And if it's A, you are manipulating the bit 2 of port A. It does not have anything to do with the port B. Alright, so the next thing is, how do you test for inputs now? How do you test for inputs? Very simple. There's a special function, there's a special C statement called the if statement. The if statement. That's what we use in testing for. You can use, there are other things you can use, but this is what we're going to be using for now at your level. If condition is true, or whether it's false or whatever the condition, just if condition is true of us, but, or you can just say if condition, no need for true of us, it can be any condition. Once that condition is true, whatever is in these braces will be executed. If the condition is not true, whatever is in the braces will not be executed. So in the program we wrote, we saw something like this. We said if port B dot B5 is double equal to 1, then manipulate the LED. That is, we said you should do port B is equal to inverse port B dot B2. That's what we said you should do. This is how you test for a bit. We're testing for and why we put 1 here is because we're testing for a high. Because the way we connected that circuit, we actually said, okay, the switch should bring in a high voltage to the microcontroller pin. So assuming this LED is on here, this is 5 volts. The switch is bringing 5 volts to the microcontroller. So we need to test for high. If we're bringing low to the microcontroller, let me change this. If we're bringing low to the microcontroller, then we'll be testing for 0 there. Here will not have to be 0. But since we're testing for high, we can put it at 1. And then there's one more thing I need to tell you about. Pull down resistor, because in our case we're testing for high. So we need to pull down this line. We need to pull down this line with a resistor. and take it to ground. A 10k resistor is always enough because the resistor has to be weak. Don't use 100 ohms for pull down. You will just be you interfere. It will interfere with the signal that you're bringing in. So you need to put a weak resistor so that it won't interfere with the signal. 10k is usually good enough. So what this pull down resistor is doing, it is making sure that only a true 5 volts, only a true high voltage can go into this place and trigger the controller. Because sometimes even without you pressing this switch, the controller can get signal and then to do what it's supposed to do, even when, but you don't want it to do it at that time, but because it got a false signal, it will just do it. So that's why the pull down resistor is very important. So that's all about inputs and outputs, and see you in the next videos.